Hello friends, I hope that you are good, well and fine. Today we will be seeing the concept of increasing and decreasing of functions using derivatives. So let's see. So derivatives help us to find that the graph or the relation is going to increase in some particular interval or some particular time, or going to decrease in some particular time period or in some particular given interval. Okay, so derivative helps us to find that also. Okay, in previous classes of application of derivative, if you recall, what we consider is the rate of change. Yes, we saw application of derivative as a rate of change, that if one quantity or one thing is increasing or decreasing or the rate is given, then how that rate affects the another quantity rate. Okay, if you can think the area. Okay, area of a circle is pi r square. Obviously, if you increase the radius in a some specific order or a specific rate, then area is also going to be increased. Yes, if you decrease the radius, then area is also going to be decreased. So that will also can be interpreted by using the increment and the decrement of a given rule or given a function using derivatives. So let's see. Okay, so let I be an interval of, okay, the every word, everything is very crucial here. So please give your full attention. So take I be an interval. Okay, take any interval, but interval containing in the domain of a real valued function. Okay, you are taking your interval. You are taking your interval in such a manner that it is a subset. Okay, or it is a part of a given function's domain. Clear? Okay. Then f is said to be increasing. First, increasing on I if when it's said to be increasing on I, if x1 is less than x2. You picked 2 points. You picked 2 points. One is x1, another is x2. In what manner you have picked? You have picked those 2 points in this manner that one is less than the another. Okay, clear? Okay, like we assumed here that x1 is less than x2. Okay, in interval, so you have your interval I, you pick 2 points from that interval, and in that interval both of the points are not same. Okay, you are picking two different points. This means if you are picking two different points, then either of them must be greater than and other one must be lesser than that. So we are assuming that x1 is lesser than x2. This means x2 is greater than x1. Simple. If function is increasing, this means that the lesser value will give me the lesser output, and the greater value will give me the greater output. This is what given here. If function is increasing, this means the value which is less, this means the output will also be less than the x2 value. As x2 is greater than x1, this means the output will also going to be greater than x2. Simple. Okay, so if this is happening for all x1 x2 belongs to what? Belongs to the interval I we picked. Okay, then you can see your function is increasing in that interval. Okay, we are talking about only on the interval. Now, if function is decreasing, then what it means? You pick two x1 and x2 in this interval I. In what manner? In manner such that x1 is less than, or x1 is greater than x2. x1 is greater than x2. This means as function is decreasing means in this manner decreasing. Yes, decreasing, this is what? Decreasing. This means x1 is somewhere here and x2 is somewhere here. Sorry. Let me, okay. So this sign must be in this way, and this thing is still happening. So your function is decreasing, your x1 point is somewhere here, your x2 point is somewhere here. As you can see, x1 is less than x2. Yes, x1 is less than x2. As function is decreasing, that's why you can say the output for x1 must be greater and output for x2 must be lesser. Why? Because your function is decreasing. Decreasing function shows this. Decreasing function shows this. So this means what? That x1 is less than x2 if f increasing means this means f is increasing like this. Yes, this means pick two value in such manner. This means f of x1 and f of x2, the inequality remains the same. Okay, but in decreasing means this downward, decreasing means fall. So this means you pick x1 less than x2, then f of x1 and f of x2, the in decreasing functions the inequality get reversed, as you can see. Okay, clear? So far so good. I hope that this point is very clear to you, that when do we say increasing, when do we say our function is decreasing. Okay, we can only say increasing when this thing is happening, when this whole thing is happening for every x in the interval. And if such thing is happening, what thing, that x1 less than x2, but this thing is happening greater, fx1 is greater than fx2, then you can say that your for if this such thing is happening for every x1 x2 in interval, then you can say that your function is decreasing. Okay, your function is decreasing. I hope that it is clear to you. Okay, let us move to next. Now the third, if on I, on the interval I, if fx is some c, if fx is your constant for every x in that interval where c is your constant, then what is happening? Then this means what? This means that decreasing, the fourth point says decreasing on I if means x1 is less than x2 in I implies f of x1 is greater than, as you can see here, inequality is this, after applying f the inequality reversed, then you can say that your function is decreasing. Okay, and strictly decreasing means when you have this means you have a strict inequality here. Okay, clear? I hope that it is clear to you. Okay, so what do we mean by decreasing? What do we mean by increasing? What do we mean by decreasing? What do we mean by strictly decreasing? All this. Okay, let us move next. Now see from diagrams. So strictly increasing means, as you can see, the graph is always going upward. Strictly decreasing means graph is always going downward. Neither increasing nor decreasing means, as you can see, it is not either going upward not going downward, it is just constant. So neither increasing nor decreasing function, so constant function. Okay, clear? Okay, let us move next. Now definition. So let x naught be a point in the domain of the definition of real valued function, okay, of f. Then f is said to be decreasing at x naught. Okay, So far so good. So f is said to be decreasing at this point if there exists an open interval I containing x naught such that f is increasing or decreasing respectively in I. Okay, clear? You will see the definition getting clearer when you face some example, when you see some problems. Okay, I hope, but I hope that this is somewhat clear to you. Okay, let us move to next. Now we have to show that the function is increasing. So how you are going to show that the function is increasing? So very simple, by the basic definition. I'll be showing this by quite simply. So pick any 2 points. So we are talking about on R. So pick any real numbers. So if x1 and x2 from reals in such manner. Okay, clear? In this manner, then what is happen? Okay, so this means f of x1 is what? F of x1 is what? 7 of x1 minus 3. And f of x2 is what? 7 of x2 minus 3. So far, so good. Now, what is happening? As x1 is less than x2, this means from this, you can say that 7 times of x1 is also going to be less than 7 times of x2. Yes. From this also you can say that x1 minus 3 is all less than 7 times of x2 minus 3. Yes, and this is what? That f of x1 which is less than f of x2. So this means this satisfies your increasing definition. So this means your this function is increasing on whole R. Yes. Okay. This thing you can do for every x1 and x2 from R. Okay, I hope that this is clear to you. Very basic thing we are doing. The use of inequalities, use of function. That's it. So from this, you can say that your function given is increasing. Okay. Okay. Now, suppose now we will use the concept of derivative. So find the first order derivative, which is d over dx. You have to find d over dx. So this means f prime x will be what? D over dx of 7x minus 3, which will be equals to just 7. Now, if this 7, you know that this 7 is increasing, greater than 0. So this means that, and this is greater than 0 for every x belongs to the real number. So this means if f dash x is positive for every x belongs to the interval, whatever the interval we are choosing to take. Okay, so this means if this satisfies, then your function is increasing. Okay, your function is increasing. If this happens, then your function is decreasing. Okay, I hope that it is clear to you. Okay, so we show that of using derivatives and of using normal inequality, that this given function is indeed increasing on whole real numbers, set of all real numbers. Okay. Okay, now we'll show that this thing is strictly decreasing on this interval minus pi by 3 to pi by 3. This means minus 60 degree to 60 degree. Okay, clear? Okay. Now what? Now find f dash x. So find f dash x. This will be sec square x minus 4. Sec square x minus 4. Now what is happening? You all know sec cos x is less than equal to 1 and greater than equal to 1. If you square it, what you will know? This will happen. This means this will happen. Okay, this is positive, less than 0 to 1. Okay, this value cos square x value is 0 to 1. If you reciprocate, okay, if you reciprocal it, what will you get? If you reciprocal this thing, if you do what? Reciprocal it. Clear? Then what will happen? Then, so first of all, let me just do what? That this is what? F dash x is this thing. So far, so good. Okay. Now, if you try to see one thing, is this increasing or decreasing in this interval? Is this increasing or decreasing? So let me just use the graph. So using the graph, you all know the graph of sec x. This is the graph of for sec x. Okay. Sec x is not defined on pi by 2, minus pi by 2. Yes, and minus 3 pi by 2 and 3 pi by 2, the odd multiples of pi by 2. But we are only talking about minus 60 to 60 degree. This is 90 degree. Yes, this is. So 60 degree will be somewhere here and minus 60 will be somewhere here. So we are talking about this place. This will be 1. Okay, clear? Okay. You all know what you know, that from minus pi by 2 pi by degree, the sec x will be what? As you can see, it will be greater than 1. As you can see, greater than 1. But at pi by 2, sorry, pi by 6, this point, red point, we are taking as pi by 6. Oh, sorry, pi by 3. Pi by 3, the 60 degree. So pi by 3. So this will be the max to max. It can go to pi by 3. So sec pi by 3. So sec pi by 3 means this thing. This means 1 by 60. So 1 by 60 is half. Yes, you all know that. This means 2. So if you square it, you all know this will going to be this thing. So what is happening? Just be careful that your sec square x will be 1 to 4. Yes, cannot be greater than 4. This means if you subtract 4 to every side, you will get minus 3 less than equal to sec square x minus 4 less than equals to 0. So this means as you can see, but we are talking about open interval. So this means you will get what? This will be equality, but here you will use strict inequalities. Yes. This means your sec square x minus 4 will be negative, as you can see. Yes, in this interval, in this specific interval, you can see that what is happening to you, that your sec square x minus 4 will be some between minus 3 to this, inside this. Okay. So this will be, it will be your negative. So negative means what? Decreasing. Strict negativity means strictly decreasing. So we showed that if your derivative of x is negative for every x belongs to what interval? Minus pi by 3 to pi by 3. We are talking about minus pi by 3 to pi by 3. You will get 0. Sorry, you will get negative derivative. So negative derivative means strictly decreasing. Okay, clear? I hope that it is clear to you. Okay, so if you also want to see that sec x will be strictly less than 2 and strictly greater than what? As you can see, at minus, what you will get at minus pi by 3, you are also getting sec x value, what? This thing. Okay, clear? I hope that it is clear to you, as sec x is positive, sorry, or even function. I hope it is clear to you. So this is simple to show that your function is decreasing. Now this, so you have to show that is increasing and for which value it is decreasing. Okay, so let's see. So for increasing, this means I have to take f dash x greater than 0 and f dash x less than 0. So this means find y prime. Y prime will be 4x cube minus 4x square. This thing 4x cube. So 4x cube minus 4x square. So taking 4x square common, you can see that what is happening. So now this thing is positive. You all know x square is always going to give you this thing is either equal to 0 or positive thing. Now what about this? This will be positive if x is greater than non-negative, if x is greater than equals to 1, and if give you negative if x is greater than less than 1. Okay, clear? So this means what? So combining all of the information, you will have if x is greater than equals to 1, then your y prime will be this thing. And if this y prime will be negative if x is less than 1. You can see that if put any value less than 1, what will you give? You will have what? Say put 0. 0, then it will be negative. So your derivative will be negative. So whenever you choose x less than 1, you will be facing what? Function as decreasing. And in this interval 1 to infinity closed interval, the function is increasing. I hope that it is clear. Okay, or 1 to minus infinity, it is decreasing. Clear? So we just use simple information of derivatives, that when do we say increasing, when do we say decreasing. And also we are using what concepts? We are using some logical reasoning that this is always going to be positive. So this means the only thing which gives you positive or negative term will be this thing. So we have to analyze this thing carefully. We have to analyze this thing carefully. Okay, I hope that it is clear to you. Okay, let us move to next example. So another example, this. So we have to show that for this it is going to be decreasing. So f dash prime will be root 3 cos x plus sin x minus 2a minus 2a. We already know that a is greater than equals to 1. A is greater than equals to 1. This means 2a is going to be greater than equals to 2. So far so good. Okay. Now you have to show that it is decreasing in R. So it is what? Decreasing in R. Okay, so far so good. So this means what? That you have to show that it is, the whole thing will be negative. Okay, so how you are going to show that? Quite simple, quite easy way. In a quite easy way you can show that. How? Let's see that. So first of all, you all know what you all know, that this cos x, okay, plus root 3 cos x plus sin x minus twice of a. This will give you what? As you can see. Okay, let me just show you. If put this as equals to 0, so you will have this thing plus sin x is equals to twice of a. Okay, so what can you think? Clearly, if you can come up with some this sort of something trigonometric rule, something like that. Okay, so let me use different approach. What approach I will be using? That as I want to know that it is decreasing, this means I have to somehow show that it is going to be 0. Okay, one thing is already given to me, a is greater than 1 and 2 is greater than 2. Now what is happening, that this expression is subtracting from this. This means if I somehow showed that this whole expression is less than 2, this means this less than 2 minus 2, this will be what? This will be some negative number. Then it can already we concluded that it is going to be negative number. So can I show this? Yes. So please remember what I will be using. I will be using a trick, a thing. What thing? That whenever you are given with a cos x plus b sin x, whenever you are given with a cos x plus b sin x, remember always this will always be less than a square plus b square but greater than minus of a square plus b square. So this means here a is root, okay, here a is root and b is just 1. So this means 3 plus 1, and this is also means 3 plus 1. This means 4. This means what? 2. So this is less than 2. You showed that this is less than 2. This means what? That if this is less than 2, this means this whole term is less than 2. Whatever means less than 2. This means any number minus less than any number. So this number is less than 2. So this means what? Less than 2. Okay, so far so good. So it cannot exceed 2, but this can exceed 2. So this means number less than 2 minus number greater than 2. This means the output will be negative. The output will be negative. So this will imply f dash is going to be negative. So that's why we said that it is decreasing on whole R. Okay. Clear? I hope that now it is clear to you. So that's it for now, and we will end up our session here. So we will be back soon with the more applications of derivative and the problems related to this concept increasing and decreasing. So thank you for watching this.